2 assignments. Any questions on any of the assignments so far? So what we're looking at today is the converse of the parallelogram theorem. And some of the theorems, or most all the theorems that we looked at yesterday. The first one is the parallelogram opposite side converse. If both sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. And we also have if both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram, which is the opposite, the converse of what we talked about yesterday. Because when we talked about this yesterday, we said if a quadrilateral is a parallelogram, then the opposite sides are congruent. Then we said if a polygon or a quadrilateral is a parallelogram, then the opposite angles are congruent. So the converse is also true. So if we can show that the opposite sides are congruent, then we can show that it's a parallelogram. If we can show that the opposite angles are congruent, then we can show that it is a parallelogram. So, looking at this here, an amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth higher and higher until it goes over the top and around in a circular motion. In the diagram below, AD and BC represent 2 of the swinging arms. DC is parallel to the ground. Explain why the moving platform AB is parallel to the ground. Well, we know that these 2 are parallel, yes? Well, if we could say that figure ABCD, this here, let's get a pen out. If we can say that this figure here is a parallelogram, well, we could say what? That AB and DC are going to be congruent and parallel. Because if it is a parallelogram, it contains 2 sets of parallel sides. Well, can we say that it's a parallelogram? ABD is a parallelogram. Because of what? Because how can we say, what do we have? Do we have any angles? What do we have? Sides. So the side lengths, the opposite side lengths are congruent, yes? The parallelogram opposite side converse. Because of the side converse. Because the parallelogram opposite side converse states that if the opposite sides of a quadrilateral are congruent, then it's parallelogram. Which means, thus, we can say that AB is parallel to what? DC. And it's parallel to the ground. So much writing. Any questions on this here? All right. So looking at this here, in the quadrilateral ABCD, we are told that AB is equal to BC. So we can mark that. AB BC. We're also told that CD is equal to AD. Can we say that this is a parallelogram? No. Opposite sides are not congruent. Because for this to be a parallelogram, the opposite sides need to be congruent. The consecutive sides are congruent, but that does not make it a parallelogram. Questions on this here? Let's look at the next one. In quadrilateral WXYZ, the measure of angle W is 42 degrees, the measure of angle X is 138, and the measure of angle Y is 42 degrees. Find the measure of angle Z. So W is 42. X is 138, and Y is 42 degrees. Do we know anything else about the figure? All the angles add up to be 360. It would be very tempting for this here to say that automatically Z is 138 degrees because Z and X are on opposite sides. So they should be congruent. But we can only say that if it is a parallelogram. Have they told us that it is? No, they told us it's a quadrilateral. So what we can say is that Z, angle Z, plus 42 plus 42 plus 138 is 360. Now, if it does work out that this is 138 degrees, then it would be a parallelogram because the opposite angles would be congruent. Now, the first thing we can do is actually add our like terms. Well, 42 and 138 would be 180, and 180 plus 42 is going to be 222. Now from here we can subtract 222 from both sides, telling us that Z is 138 degrees. So we can definitely say that this is a parallelogram because so yes, the opposite angle, what is it? Yeah, I was missing a word. What's it there? So it is yes, and it is our parallelogram opposite angle converse. Questions on this here? Kind of nice, isn't it? Actually read it for once. Okay, let's look at the next one here. For what values of x and y is the quadrilateral a parallelogram? Well, did they give us sides or angles? Angles. So for it to be a parallelogram, the opposite angles need to be congruent. So for us, that means that these two need to be congruent, yes? So 4y needs to be equal to y plus 87. And these two need to be congruent. So 2x needs to be equal to 3x minus 32. Which one do we want to solve for first? Y or x? X. We can do either one. We'll have to do both. So if we solve for x, what do we need to do first? Subtract 3x from both sides. Yes? 2x minus 3x is? Negative 1x is equal to negative 32. Yes. Because if negative x is equal to negative 32, so positive x should equal positive 32. We could have also gone about it by multiplying both sides by negative 1 and gotten to the same thing. So we found the value of x. So what do we need to do over here to find the value of y? Minus y. Because unfortunately we don't have any like terms on both sides because of the equal sign in the middle. So we'll have to subtract y from both sides. 4y minus y is 3y. Y minus y is 0, leaving us with 87. And then we would divide both sides by 3, telling us y is equal to 8 would be 2, 6, 9. Well, 87 is 3 away from 90. 90 divided by 3 is what? 30, but it's 3 less than it, so it would be 29. Does that kind of make sense? Quick math. Any other questions on this here? For what values of x and y is this quadrilateral a parallelogram? Well, the last one we said the opposite angles, if they are congruent, then it is a parallelogram. Well, we also know what? The opposite sides. So these two would have to be congruent. So y would need to equal x plus 7. And we also would need that 2x minus 1 is going to equal x plus 9. Can we solve for y first? No, because in y equals x plus 7, in that equation we have two variables. And at most, we can only solve for 1. Now, in the other equation, I have 2x minus 1 is equal to x plus 9. I only have one variable. So we can solve for it first. What can we do first? Minus x or add 1? Either one. Because we can add 1 here. Because if I add 1, negative 1 plus 1 will cancel, leaving me with just 2x is equal to x plus 10. Then what can we do? Now we can subtract x. 2x minus x is x equals 10. Now realistically, we could have added 1 because here we added one first. We could have subtracted x first. Either one would have gotten us to the same answer. Now over here we know y is equal to what? X is 10 plus 7 because we plugged the 10 back in. Now 10 plus 7 is, so y is 17. Because if we look at this here, we're saying y is 17. Well, x is said to be 10. Here 10 plus 7 is 17. Here 9 plus 10 is 19. Well, 2 times 10 is 20, but 20 minus 1 is 19. So we do have that the opposite sides are congruent. And that's it. Questions on this here? We feel good with these here? Do we need to see another example of this? And one of the things I will say, especially when we have not exactly this setup, but especially when it looks like this here where we have one variable, two different variables in an equation, try to look at other slots that work. Like if we were working with the stuff yesterday and having these angles here, just because these don't match up as the same variable, maybe we could go the other direction, or we could use that the opposite angles are congruent. Look at all the different ways that we know that this different parts of the parallelogram are congruent, because it might work out that one of those setups, one of the ways that we could set it up using that, has the same variable. Does that make sense? Because I know for sure one of the homework assignments last night had 3 different variables in it, and you had to pick the correct way to set it up first to be able to find the others. Okay. These are the last 2 theorems that we have today, unless I'm mistaken. Now the first one is opposite sides parallel and congruent theorem. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. This one seems odd that we can say that it is a parallelogram, yes? With just one set of sides being congruent and parallel. So we know that the distance from A to D is going to be the same distance as B to C, yes? Same distance, so they're not, one of them's not closer to the 2 points, endpoints are not closer than the other, yes? 2 lines are parallel if they do not what? Touch or cross, yes? And for them to be able to cross, that means they would have to get closer together, yes? Or go farther away in one direction or the other. So wait a minute, if A, D, B, C are the same, is there any way for line A, B, and CD to get any closer to each other? No, because they're going to be the exact same distance, yes? So that means that these have to be parallel. And now that we have that, we know that it is a parallelogram, because by definition, a parallelogram is a 4-sided figure with 2 sets of what? Parallel sides. So it is a parallelogram. That's why this works. And the other one, parallelogram diagonals converse. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Just the opposite of our diagonal converse. The doorway shown is part of the building in England. Over time, the building has leaned sideways. Explain how you know that SV is equal to UT. We want to know, how do we know that these two here are equal? parallel and congruent, which by our opposite sides parallel and congruent theorem would make this here a so by opposite sides parallel and congruent, circle that whole thing, Theorem, STUV, I had a feeling I was going to do that, STUV is a parallelogram, and what did we want to say? SV, that SV is equal to PU or UT. Questions on this here? State what theorem you can use to show that the quadrilateral is a parallelogram. So we look at this here, well, we have two sides that are both 30 and they are parallel, yes? Well, that's what we just used, isn't it? Opposite sides parallel and congruent theorem. Well, this next one would be what? The parallelogram opposite sides converse. Well, the next one would be what? Parallelogram opposite angle converse. All right, we have 3 more problems on this note sheet. And if we look at this here, we want to know for what value of x is quadrilateral CDEF a parallelogram? Well, if this is a parallelogram, the diagonals do what to each other? They bisect each other. They cut each other in half. So for this to be a parallelogram, we would need that these two lines to be congruent. So we would need that 5x minus 8 is equal to 3x. What can we do first? We can add 8 to both sides. Negative 8 plus 8 would be 0, telling us that 5x is equal to 3x plus 8. Then what can we do? Subtract 3x from both sides. which will tell us that 5x minus 3x is equal to 8, because 3x minus 3x is 0. Then what can we do? Divide both sides by 2, which tells us that x is equal to 4. So the value of x that would make this be a parallelogram is 4. That's it. If we wanted to, we could plug it back in and see. Well, 3 times 4 is? Now 5 times 4 minus 8. 5 times 4 is 20 minus 8 is? So indeed, that is the correct answer because it gives us 12 for both side lengths, or both lengths, because they wouldn't be sides. Questions on this here? Let's look at this one here. So again, if we want this to be a parallelogram, these two lengths need to be congruent. So we would need that 11 is equal to plus 17. What can we do first? Add 11. Negative 11 plus 11 is 0, telling us that 4x is equal to 2x plus 28. Then what would we do? Subtract 2x. 4x minus 2x is 2x minus 2x is 0, leaving us with 28. And lastly, we would divide both sides by 2, telling us x is equal to 14. And that's it. Any questions on any of this here? Do y'all feel comfortable with this here? Okay. So, ways to prove that a quadrilateral is a parallelogram. One is just by the definition, because if we have two pairs of opposite sides or two pairs of parallel lines in a four-sided figure, then it's a parallelogram. Show that both pairs of opposite sides are congruent, because if we have a quadrilateral with opposite sides congruent, then it's a parallelogram. If we can show that the opposite angles of a quadrilateral are congruent, then it's a parallelogram. And then if we have that one set of opposite sides is parallel and congruent, it'll be a parallelogram. And lastly, if the diagonals bisect each other, then it'll be a parallelogram. So we have 5 different ways to show that a four-sided figure is a parallelogram. And that's it.